Okay, we are here to talk about secant lines, and I picked a problem out of our book. It's the problem about a rock being thrown up on Mars. All right, so let's put that problem out here. Okay. Okay, here we go. We have got this rock on Mars that is being thrown upwards at 10 meters per second. Gravity on Mars is less than Earth. Actually, let's wait. We shouldn't just assume this to be true. We should actually go and test this out. Let's go to Mars and see what gravity is like. All ready? Ready? Here we go. Wow, here I am. What a view. Okay, while we're on Mars, let's check out Martian gravity, shall we? I picked up a piece of Martian rock here, and I'm going to throw it up and see how long it takes to come down. Ready? Kind of slow. There we go. So, I'd say we go back to the classroom and do the calculations, okay? Okay, I'm back. All right. Gravity is less on Mars. Let's solve this problem. Here we go. We've got these intervals from 1 to 2 seconds, from 1 to 1.5 seconds, from 1 to 1.1 seconds. Over that interval, we can find an average velocity. We do that by just simply finding the slope of these 2 points. All right. So if I plug in 1 second to get my initial point at the beginning of each interval, 1 is going to be 10, and then minus 1 squared, 1.86. That's going to give us 8.14. So we know that our initial point is 1 and 8.14. Our second point then is going to be 2, well, 2 squared is 4. 4 times 1.86 is 7.44. Subtract that from 10, or from 20, because at 2 seconds, that's going to give me 12.56. So I simply find the slope between those 2 points. So I can do 12.56 minus 8.14 all over 2 minus 1, which is equal to 1. So if I subtract that, 8 from 12 is 4, and 14.14 from 56 is going to be 42. All right, so that is the average velocity of this. It's going down, so we're actually dropping. Nope, we're going up. Okay, so from 1 to 2 seconds, it's still going up. I guess that's right. So that is our average velocity. We need to do this now for each of these intervals, all right? It can be kind of tedious, especially when the numbers don't cooperate, all right? Yes, you can grind it out, but, you know, mathematicians are a lazy bunch, and we always try to think of a way to do this faster. You maybe would know how to do it on an Excel sheet, but we can do it on our calculator, so I thought I'd show you that really quickly. If I come around and put this calculator in front of the camera, all right, you can see that if I press the program button right there, well, I have to turn it on first. That's really useful. If I hit the program button, I've got this thing called Secant. I went over and created a new program, named it Secant. I'm going to edit it now just to show you what it looks like, and it's really simple. I'm using my initial point here. My x value is 1. I'm just storing that as the variable a. I could have just used the number 1 in this case. I just can use this in the future, and it's easy to put a new formula in. Here's 8.14 for b. And then I'm going to display the floating point is the end point. All right, I can teach you how to do this if you don't. And it's going to prompt me to enter what the end point is. In the first problem, it's going to be 2, and the next one, it's going to be 1.5. Okay, and then I've got just this formula: 10 times whatever c is minus 1.86 times c squared. That's going to be stored as the output d. And now I've just got the slope formula here. Okay, and then in the end, I'm going to display the answer. So if I just quit out of that and then hit enter, and I hit program and then do execute the program, there it is. I hit enter, and I can type in, for instance, 2 is my endpoint, and there it gives me 4.42. I can type in 1.1 and hit enter, and whoops, I need to restart that program. Sorry. You always want to make sure that program. There it is. I want to make sure I get that C question mark. If I type in 1.1, I will get that as the average velocity over that smaller interval. I hit enter again, and it'll give me the C with the question mark. Now I can type in 1 point, oh, I should have done 1.5, but anyway, I'll just jump to the end, 0.1, and that's that, 6.26, and then I can do enter again, 1.001. You see this is a lot faster, and I'm a lot more confident that I haven't made a mistake, and it's a lot less tedious. Plus, I can keep going. I can do 1.000001 if I want, and I'm getting a velocity that's over an incredibly small time frame, and I can guess that the limit here is likely to be 6.28. Okay? Save that answer, and we can come back to it later. Hopefully that was helpful. Thanks a lot.